about ready to move on to the next phase of this, and that is boring this hole to 3/4 to fit the pin. And we still got to drill the hole in the back of the tube right here. That's this guy right here. It's a roll pin that fixes the actual pin right here to the housing. But we're going to start with this first right here. And I believe the way I've decided to do this is I want to line this up. I'm going to indicate this side of the hole. Since this is machined on this side that it's sitting on there, I'm going to go ahead and set it on the mill table just like that. We'll use the do-all over here, the little knee mill, and I'll use a coax and center up on this hole. And I believe I can reach down through here to the other hole, which will be on the bottom, and see how close I am. But I feel like they're very, very close. Now, one way you could do this definitely is using a boring head. To me, this is not my idea of a fun setup to use a boring head, because for such a small bar, you've got a long area right there, and you're going to be dealing with chatter. You know, you can use little bars like this, which I don't like these type boring bars. You know, you use them when you have to, but I don't necessarily like them. But so you got to have a nice long. That's a 4 inches from end to end there. So that one right there wouldn't even be long enough. I'd have to grind some more of the shank off. So I'd have to find another bar that's more suited for that. Preferably just like a 3/4 boring bar that takes a little high-speed tool bit. If I indicate this and these things are off quite a bit, then that's probably what I'll end up doing. But if they're very, very close, what I'd like to do is use this R8 to Morse taper adapter and use a reamer to finish it to size. This is a 3/4 reamer. There's a good one right here. I believe this is a Morse. I'm sorry, that's a Hercules. A 3/4 reamer. So I have to use a reducer bushing to bush it down right here. And of course we'll drill it first and bring it to size. So while we're over here messing with this is the pin that's going to go through this hole right here. Actually, it goes the other way. Snap ring will be on the bottom right here. And since I haven't shown this yet, here's the part that John Saunders has made. And he's got a good fit on that pin right there. Now I mic this pin, and it mics 1/1000 under 3/4, so it measures 0.749 inches. It's got a nice fit. The original Kearney Trecker, seems like there's got one little spot down here on this end of the hole where it's got a little ding or something, a little bit of a flare, because it gets tight right there on that end. But it fits the same there. And so when you come right here, it fits through there too. So it's not supposed to be a tight fit, or they don't have it like a tight fit there, just very close so it's not rocking around. So I think a 3/4 reamed hole will suffice for something like this. Alright, so I'm going to go ahead and start setting up on the mill now. Alright guys, I've been setting up in the mill here, and I'll go ahead and explain my setup. And I also want to point out that we've got several new things that I'm incorporating into the shop and job setups, and just new things in general. First of all, on the camera I'm using a CPL filter, and this is kind of going to be a test to see if it makes any difference on the video. I really don't know what this is going to do, but we're going to try it. So we're using a CPL filter. Alright, another thing I'm going to point out is, I'm going to talk about this later, but I've got this LED light right here. I bought it at Lowe's, and I attached some magnets on the back of it, and I actually intended that to be for the K&T, but it looks like it's going to be handy for different machines. We're going to try that light. I've got it stuck to the bottom of the head right there and just plugged in, and I'm going to set it back down here. I'm going to turn it on, and I'm curious to see how that looks on video, if that's going to be a good amount of light or what. Now I also got this other clip light up here that I always use in my videos, and sometimes it's a little bit too bright. There it is, but it seems to put out more light, and I'm kind of used to that. I may just try both of them for now and see what it does and see if this filter helps anything. So I'm going to go ahead and run this down here, and the last thing that I was going to point out is this, get it around here. So this is that keyless drill chuck that was given to me by a viewer last year. This is the first time that I've actually set it up and used it. I was waiting to put my new drawbar in there, which I've been using that new drawbar. I didn't want to run the old one in there because of the threads being messed up. So first time I'm actually using this Vertex keyless chuck. It's built like an Albright, and that shank on this coax indicator is 10 millimeter. I don't have a 10 millimeter collet to hold it, so my next best option is a drill chuck. So I got it kind of close by eye, moved it around to kind of save a little bit of video time. We're going to go ahead and indicate this first hole. And I talked about this before. You can turn the spin along with these type of indicators and adjust it while it's running, but I seem to like the slower aspect of it, just doing it manually. I just make little movements every time until it kind of comes in where I want it. The other reason why I'm testing that CPL filter is to see if it's going to help with the dial faces of the indicator. Now in this case there may not be much of a reflection on it because the way we're looking at it. Whenever you're looking down on the lathe, you're getting the reflection from the fluorescent lights above it. It looks like we're within a thousandths here. Let's see if I can just tweak that right there. We already got this tight right here. I got it setting on parallels so that it's sitting on this body that was machined. This ear down here, whenever it was sitting here, I noticed just a slight amount of rock. It's just barely. So it's not completely flat and parallel with the body. So that's why I set it on this. Plus to get it off a little bit so we can run through with the cutter. Alright, so what I want to do now is, oh, I just caught my light. There's another downfall of having it where I got it. I'm going to take this one out. And I want to put the long straight one in and see if I can reach through and indicate that bottom hole. Alright. Not bad. I want to make sure I'm getting all this. Wow, that's not bad at all. It's a lot closer than I was thinking it was going to be. So let me count it. Looks like 4 thousandths. Right around 4 thousandths. Needle's kind of jumpy. This isn't the best setup, see, but once you get to moving, I'd say between 4 and 5 thousandths. So I'm going to run with that. I think that's going to be close enough for what I want to do. If it was way off, then we would have to bore it in line, but I think this is going to work okay. All right, we're all set up, ready to start cutting. So I'm going to use a 47/64 drill bit. That's a brand new drill, and we're using that brand new keyless chuck there. Everything looks like it's running nice and true. I want to go ahead and give this a check and make sure I'm not cutting over 3/4. Looks like I'm cutting right on what it's supposed to be, around 735. So we're looking good. I'm getting 735. There's a 737. So that'll be good for our finish reaming size there. Just using some cutting oil and one of my Eagle oilers here. The clamp is getting real close to the drill bit, so I'm going to just pull it down on the shank a little. It was almost through there. All right. Looks like a nice hole, man. That was the first time I used that drill, and it's cutting nice and true, and it's a clean hole too. Alright, so we're ready to ream. We got the tool set up. I want to point out this is actually a different reamer than the one that I showed you before. This is the one that I remembered I had, made by Morse. It's a right hand spiral cut, 3/4, and it's in really good shape, almost still brand new. Look at the setup there. Looks kind of ridiculous sticking out that far to me, but that's the tool that I got, that Morse taper adapter. Alright, so here we go. I'm gonna go ahead and get it started, and I slowed it down. We're running 210 RPM right here. I'm using power feed. I got it in the fastest feed, which is about 5 thousandths. And I'm just going to let the machine do the cutting here. There we go. Another thing that I'll add is that I had to move the table over in order to have clearance to stick this tool in the spindle. And one way you do that when you don't have a digital readout, which I don't on this machine, first thing I do is I'll put me a little Sharpie mark there, and then you zero out your hand wheel right here, making sure that you eliminate the backlash and which way you want to come back to read 0. And you just offset it, count how far you went. In this case I went 2 inches, and then you come back the other way and then reverse it again to eliminate your backlash and bring it to 0. And you're in the same exact spot. I think I've showed that before on another video. It looks like the reamer's cutting good. Some good looking chips there. Just coming through the bottom now. Just make sure you keep your reamers well oiled. Whatever lubricant you want, cutting oil, whatever, just make sure you keep plenty on it. They do like a lot of oil. It'll help your finish too. Okay. All right, let me break my tool set up out of the way, and then we'll check our pin size, or our pin fit anyway. Good looking finish in these holes, man. Nice and smooth. Really nice finish in there. I'm happy with that. All right, let me get the pin. I got it over here. There's our pin. Looks like we got a good fit. Look at that. It'll just about stay. That's nice. Nice fit. Tell you what, let me grab the other arm that John made. Let's fit it on there with the pin. Where you at? There it is. Oh yeah. Look at that. You got to push it all in there. I still got to make that pin, so I need to try to maintain that size as close as I can. Oh man, that's nice. Got very little movement. All right, looking good. So I'm gonna go ahead and break this down and go ahead and finish this last stop where we need to go ahead and drill this last hole right through there and deburr that. This part will be ready. All right, just getting her set up so we can drill that hole. What I want to do is just square it to the back of the table here. And I'm just making it very simple. I'm using a parallel. And I'm just getting it squared up on both ends. Just getting it pulled over. Alright, so our hole is 1/2 inch from the bottom, and then I found the center that way, and we're going to drill it and then ream it for 3/8. So we're doing a dream operation here. All right, going in with our 3/4 reamer. Well, that's about it for this piece right here. That's about all of the machining. There's a 3/8 roll pin that I found in my bin. That's what we'll use to drive through there. I'll have to cut it off. I don't have to, but I'll trim it so that it's kind of flush, 2.5 inches in the end there. So I am going to do a little bit of deburring here. I'm going to show you a couple of my Noga deburring tools after I get it out of the mill, and we'll go set it up on the bench and do that. We're going to use some of my Noga tools to do a little bit of deburring here. Just want to kind of show them. This is a new one that I got from Noga right here. This is the NG3400 heavy duty rotor drive. It's bigger than the one that comes on this multi-tool right here, and we use that one. That's extremely handy for deburring holes, and you can see it's just a bigger. You can go, I think, up to like a 3/4 hole with that one there. So you can use it. Let's see how it works right here. Yeah, you got rid of the burr there. These things are very sharp, so they'll really dig in if you put a lot of pressure on it. Okay. You can also use the classic style. This is my other set right here that I got from Noga with all the different deburrs. Here's your normal deburr. You can do that there. So what I one that I want to highlight from this set right here that I really like is this one. This one is made for doing internal deburring. You can reach through a hole with this guy right here. You can reach through there and scrape the inside of that hole and remove that burr, and it's very helpful. I've used this a lot. I've got 2 of them. I got another one at work, and I use it all the time. What I want to do is move the camera over here and try to get a better shot so I can show you how this works on the inside. All right, we'll give that a shot. This thing is actually adjustable too if you need to extend it out. So you just reach through. Just like that. Let's see if I can try it left-handed here. I'm used to using my right hand when I'm deburring. There we go. The internal deburr by Noga. I don't know if the rotor drive is going to work real good for that when it's right at the same diameter, so I'm not going to use that one. We're going to use our regular deburr right here. And then again on the internal ones, you can reach through with this guy and do some internal scraping. Alright, well, we'll go ahead and slide this thing together because this is pretty much finished right here before we move on to our shafts that we need to make. There it is. Everything's lining up just perfect. All of our center, we had a 5-inch center between everything, and that's what John made to this. Made this piece here too. So that's how it worked. Tell you what, let's grab the screw right here. Let's look at this for the first time. This piece here, I haven't even done this yet. Let's see what it's going to kind of look like right here. Trying to remember how this is going now. Okay, now I got it. The conical nut right here. You have a lock nut here. Alright, so that's going to fit there. This is a lock nut for the top. Look at that, bam. So, this is going to screw into the top of the vertical head there. So that'll be locked in. And then, so this will be hanging like that. And once this is swung around, you reach in here with a wrench and tighten this nut. Yeah. You're going to tighten this one up here, and I believe this, you can just kind of lock this one wherever you need to, and once you swing it off out of the way, it'll just be sitting on that that taper that we put right there. Alright, so this is done. The next step is going to be making this pin here, and we also got this pin here that we got to make for this back side. It'll sit in there like this. I still got some chips in there, that's why I didn't want to go in. So alright, hope you continue to enjoy the build, and I'm ready to go ahead and jump on the next phase and get going. So we'll see you on the next video, okay?